Hello everyone. In this lesson, we're going to talk about coordinate proofs for triangles. And with triangle coordinate proofs, we are proving classifications of triangles, which as you recall are the scalene, the isosceles, equilateral, and right triangles. So here's what you need to prove all of these different types of triangles. For scalene, well, scalene has three non-equal sides. All the sides are different. And how do you prove that sides are not congruent or different lengths? Well, that's three distance formulas. There's the D right there. For isosceles, we know that isosceles has two equal sides and then one non-equal side. So again, that's going to be three different distance formulas that you're going to have to do. For an equilateral triangle, all sides are the same. So again, that's another three distance formula. So as of right now, it's not terrible. The only formulas you need are the distance formula, and then you also need to know slope to prove that there is a right angle in a right triangle, and that's going to be consecutive sides are perpendiculars. Let me just write that in. So to prove this, consecutive sides are perpendicular. Okay, so in a triangle over here, A, B, and C, consecutive sides would be AB, and then immediately either BC or AC, the one, so the leg of the triangle that comes off of either one of the endpoints of the side. So this side over here has endpoints of A and B. So a consecutive side with that would be BC or AC. Alrighty then, let's just go straight into an example here so that we can see how we write these coordinate proofs. And it's the same way as the other one. You need to write down, well, what did you do? And then what did you prove after you show your math, right? So you got to show your math first. So this one right here, the coordinates of FGH are those, and we need to prove that it is isosceles. So we're going with isosceles, so we need to show that it has two equal length sides and then one non-equal length side. So we need to do all three of those because we need to check that third side just to check to see that it is different from the other two, because if you just do the two sides that are equal and say, hey, this is an isosceles one, you could be incorrect, and that third side could be equal to the other two sides, and then it would be an equilateral, but you haven't proven that, okay? All right, so we have to do three distance formulas. So the first two sides I'm going to do are just F and G. So I got to do the distance. Oops, there we go. The distance of F and G. Let's remind ourselves what the distance formula is. X2 minus X1 quantity squared and Y2 minus Y1 quantity squared, all underneath a radical. Now, I'm not going to label my points up here with the x1 and y1 just because it's going to get too convoluted. So I'm just going to be extra cautious of what I'm dealing with here. So my x2 up here for f and g is that one. So I got 6, and I'm subtracting positive 1. So 6 minus 1, 6 minus 1, quantity squared. And then I got my y, which is y2 is 4, and I'm subtracting 2. 4 minus 2, quantity, oops, that's a 2. There we go. And then what do we get from this? We need to, 6 minus 1 is 5. 5 squared is 25. Plus 4 minus 2 is 2. And 2 squared is 4. So this is the square root of 29. All right. So now we got to do, that's one side of it. Now we got to do the distance of G and H. That's my next one. G, H. I won't write in the formula this time because I already did it, and I can reference it up above if I need to. I'm just going to plug in. So my y, or my x2 is 8. and I'm subtracting 6. 8 minus 6, quantity squared. Add to that, my y2 is -1, subtract 4, quantity squared. This gives me 8 minus 6 is 2, 2 squared is 4. It's a good start. And then we have -1 minus 4, which is -5, and -5 squared is +25. Perfect, because that's exactly what I had up above, which gives me 29. So good, I have my 2 equal sides so far, 2 equal sides. So that I think that FG and GH are the 2 sides that make it isosceles, but I need to check that third one just to make sure that it's not an equilateral triangle. So my next pair that I need to check is FH. That's my last pair. If you need to draw a picture just to make sure which ones you have done, you can either graph it on the graph because the use of the grid is optional. If that helps you to see it, go ahead and graph it. But I'm just going to draw a picture F, G, and H. So what I've done so far is I've done FG, and then I just did GH, and now all I need is FH. So if that helps you, go ahead and draw a picture. So I got FH over here. I'm going to do that in green, distance of FH. And this is going to be my x2 is 8, and I'm subtracting 1. 8 minus 1, quantity squared. And then my y2 is -1, and I'm subtracting 2. Quantity squared. And what does this give me? 8 minus 1 is 7. 7 squared is 49. Plus -1 minus 2 is -3. -3 squared is 9. So this is going to be difference, and that's what I want. 49 plus 9 is 58. Radical 58. Perfect. So I got 2 sides that are the same length, and that third side is different. Therefore, I do have an isosceles triangle. All I got to do is just write my sentences now. This is where I formulate my argument. Okay, you need to have this. So I have triangle FGH has 2 sides congruent and, oops, I put a comma, and 1 side of different length. Therefore, triangle FGH is isosceles. You have to have both these parts, as you recall from earlier lessons. You have to have both of these in your proof. If you just stop at this sentence up here, that's just stating what you did. You didn't say what it proves. Even though a mathematician would go through and read this, oh, FG has 2 sides congruent and 1 side of a different length. In their head, they will say, oh, this has to be an isosceles triangle. But for a formal proof, you have to have this second part right here. You can't just rely on people making the connection. You need to make the connection for the reader. Okay, it's very important. All right, that's it for these notes. I will see you next time, everybody. As always, be safe and be healthy. Bye, guys.